Oh, hi. Will 80 grams of oxygen be enough for the complete combustion of 35 grams of propane? Will it or will it not? Simple question, but we have to actually solve to find out if it will be or not. Who knows? I mean, it's looking big here, right? 80 grams of oxygen should be enough to combust 35 grams of propane. At least that's what anybody looking at it may think. But let's solve. Um, yeah. To do this, I think it would be a good idea to find out what the limiting reagent will be. The limiting reagent uh is the species that gets used up first. Okay, so let's see. 80 grams of oxygen. Let's convert that to moles, shall we? We'll divide by the molar mass of O2, which will be 32. 32 because it's O2 and oxygen is 16. So the 2 there makes it 32 when you multiply, okay? So that is 80 divided by 32, which is 2.5. That's the number of moles of oxygen. Let's figure out the number of moles of this other one, shall we? Propane, 35 grams. So mass divided by the molar mass. What's the molar mass of propane? That's going to be 3 times 12 plus 8. And then let's calculate what that would be. 3 times 12 plus 8 should be 44. And then when you do that division, you should have 0.795 moles of propane. And this is of oxygen. Now, the final thing we need to do here is to divide this number of moles by the stoichiometric coefficient. So you want to divide that by 5. And you want to divide this number of moles here by what? 1. That still gives you, for the propane area, 0.795. And then for the oxygen area, would have 2.5 divided by 5. What's that? 0.44. So this is 0.7 and this is 0.4. That means that our oxygen is smaller. It is the limiting reagent. So to get used up first, if you are reacting oxygen 80 grams and propane 35 grams, the oxygen that is 80 grams will get used up first before that 35 grams gets used up. We just saw it together here. That's it. Do you agree? Yes. So that's what the calculation is telling us based on the number of moles and how it does react. So that's it. So we cannot conclude that 80 grams here would mean that it would be much. Okay? It's not even enough. It's not enough. It gets used up before the propane. As a matter of fact, you can calculate how much of the propane would remain after all the oxygen gets used up. So you realize that not all the propane will remain. So that's it, and that's how to answer this question based on limiting reagent calculation. Let me know if this was helpful to you. Did you learn anything new? I believe we've looked at limiting reagent calculation right from video number 3 or so. Yeah, but then this is an application question. So if this was helpful, you can leave a comment. Let me know. Subscribe if you're seeing this on YouTube. Just click the subscribe button now so that you subscribe and see 87, version 87. All right, so I'll see you soon. Bye bye.